Hi, I'm Albert Vega, president of Building Momentum, and
Hi, I'm Julia. I'm a training engineer here at Building Momentum.
today we're going to do a little bit of fun with 3D printed objects. So one of the things that everybody loves about 3D printing is it does a lot of cool stuff, it builds a lot of neat things, it's a very great tool. But the problem is that a lot of people forget that, the material that goes into it is actually extremely important. The 3D printer is a great tool, but the 3D printed material is just as important. So what we're going to do today is we're going to break a bunch of these 3D printed carabiners, and they're made out of different materials. This one's PLA. We also have some out of ABS, polycarbonate, and two different types of materials from a Markforged printer called Onyx. We're going to just see how they break and what force they break at. So we're going to do a little qualitative analysis. Now we're going to be using a computer to measure all the forces coming out of it. We're going to get a quantity, but since all these objects were not printed on the same printer and they weren't used, the same slicer wasn't used to cut up all the models into how they want to be made, it's not going to be exactly the same across each model, so I'm not calling it a true qualitative analysis. So Julia and I came up with this really cool idea. Julia did all the welding, and this system here actually, as we ratchet this nut, will pull this entire system this way and apply force onto something via this strap. And hopefully this will break bridges and our carabiners. We have a little load cell here that I bought from Amazon, and this thing here will be giving all the information over here. This is our setup. We have a little Arduino that's going to communicate with this amplifier, and this is going to read all the signals from our load cell, and we'll display all our information here on the computer, and it'll record the maximum amount of force that is used just when our carabiners, or in the future, bridges break. So let's get to it. Let's start breaking some carabiners and hopefully soon breaking some bridges. Let's see where it broke. Looks like it might have broken a couple different points. Looks like it snapped there, and it also snapped where it was holding the carabiner. And it kind of just went off in a couple different places, but what our maximum weight was 154 pounds. So good start for PLA, not bad, but it can't hold my weight. All right, so we broke all of our 5 carabiners, and the Onyx with continuous fiberglass won the challenge, held the most amount of weight. But let's take a look at how every single one of our carabiners broke, and then maybe we'll get a little feel for what failed. Was it the material? Was it the design? And I think if we examine all 5 of these, we'll get a little bit of a feel for what's really going on. So if you want to take a look, here we have our PLA, and we can see it broke in a couple different places. It broke on the little clasp on the hook for the clasp, and it also broke on the arm. And if we look over here at the ABS, we can see that it broke in a completely different place. It broke right here where the arm kind of extends from the body of the carabiner, and it also broke on the hook for the clasp. Moving one down to the Polymaker polycarbonate, we see that, again, the hook for the clasp broke, but this is also really interesting. It broke dead in the middle of the arm, much like the PLA did, but it also broke, again, kind of in the neighborhood of the elbow from where the arm actually meets the rest of the body. Now we move over to the Onyx. This one was really interesting. It looks to be a really tough material because the hook for the clasp, nothing at all. If you look at this, man, that's in great shape. No problems at all. But it broke right at the elbow from where the arm goes into the body of the carabiner. So maybe that's an interesting one because we've seen this story before. Maybe that's part of the design. And if we look at the Onyx with fiberglass, again, you can see the hook for the clasp is still in great shape. But again, it's failed in the same place, right in the elbow between the arm and the body of the carabiner. And you can see the little white material in there. That is the fiberglass that is inlaid in the Onyx material as it's printing. So again, Onyx with fiberglass got 189.7 pounds. The Onyx just by itself got 167.7 pounds. The polycarbonate 170, ABS 127, and PLA 154. So again, kind of just overall demonstrating the importance of materials in 3D printing. It's just not the 3D printer, it's what you put into the 3D printer makes a lot of a difference. So thanks for tuning in. We hope you learned something, and you know, if you make something out of a 3D printer, send it to us, we'll break it for you.